The 2012 higher level question 6, the ellipse and parabola question. The question, the figure shows a logo for riding stables. The curve AB is parabolic with, so it's parabola with vertex at B. The curve TDE is a portion of an ellipse. The points F and F1 are the focal points of the ellipse. The line BT is a tangent to the ellipse from B. The curve LM, which with vertex at L, is identical to a portion of the ellipse. The line RS is tangent to the circle from S. Locate the centre of the arc APS and draw the arc. And draw the given logo showing clearly all construction lines and points of contact. There's quite a lot in this question in the information that they give us in comparison to some of the other ones. But when we look at it, it isn't actually too bad. So for our parabola, we're given the height and width of 1/2 of the rectangle that we'll need for drawing that, so that's okay. The line, the arc APS can be found relatively easy. Again, that isn't too bad. For the ellipse, we are given the size of the minor axis. Size of the minor axis is half the minor axis is 32, but we're not given the major, but we are given the position of the focal point, so that allows us to do that. So that's what we're going to start with first, is drawing the ellipse. So what we have at the moment are these are the two focal points, F and F1. And what we're going to do from here now is find the size of the minor axis. So the size of the minor axis, we're told, is 32, or half the minor is 32. So we have a point on the end of the minor axis. So what we're going to do is measure the distance from the end of the minor axis to the focal points. And this distance that the compass is currently set to is equal to half the major axis. That's the same on both sides. So marking to focal point, so that distance here. So measuring that distance now from the center of the ellipse, so from where the major and the minor axis cross each other. Marking that distance on the major axis gives us the full length of the major axis. So those marks beyond the focal point are the ends of the major axis. So now what we're going to do is we're going to use whatever method we prefer to use. So you can use the Trammell method or the auxiliary circles method, and use the auxiliary circles method to draw this ellipse. So swinging an arc for the major and for the minor, auxiliary circles. Now, just like we normally do, we're going to divide this up with into a number of different points. So you can take random points, which is what I'm going to, random lines through this, which is what I'm going to do right now. So dividing the spaces evenly as I can. You can use your 60-30 degree set square if you wish. It won't make any difference. So what we're going to do from each of these points, so we got 3 points already, 4 points on our curve already, 1, 2, 3 and 4 at the end of the major and at the end of the minor. So there are 4 points. And what we're going to do from each point, so we're going to take each line in turn. So this one here, this one cuts the major auxiliary circle, so we're going to go perpendicular to the major axis. So that's going to be a line coming down this way at 45 degrees. This same line cuts the minor auxiliary circle here, so perpendicular to the minor axis is a line coming this way. So if you get this first step right, you're flying for the rest of the ellipse. So perpendicular to the major axis, perpendicular to the minor axis. So cut by the major auxiliary circle, perpendicular to the major. Cut by the minor auxiliary circle, perpendicular to the minor. So keep doing that. And the same up here again, so perpendicular to the minor axis as it's cut by the minor auxiliary circle, cut by the major, and and this one up here. So that gives us points on our curve. So now we can draw the best fit curve that we can that goes through each of these points. So draw this slightly as there is a tangent at the far side over here. And we don't need any of the curve down in here, so we can leave that one. And that gives us our ellipse. Okay, so that's the ellipse done, or the first part of it. We'll come back to doing more of that, or we'll do the tangent to the ellipse now. So we've got point B, which is this point up here, and we are told in the question that the line BT is a tangent to the ellipse from B. So it's a point outside the curve, and so we need to find where that touches in here. So what we're going to do first, put the point of our compass onto B, pencil onto the nearest focal point. Now we're going to swing an arc up here. Now measuring the length of the major axis with the compass. Major axis with the compass, and then put the point of the compass on the second focal point, the one that we haven't used yet. Putting that on here, swing an arc to cut the first one. And now joining where those two arcs cross each other back to the second focal point that we used. Where that intersects the curve, or it intersects the ellipse, is our point of contact. So I can label that POC, and that will be point T that we're looking for. So that can join now to point B. Now we can darken in the rest of this here. That much. So that gives us the tangent there for line BT. Next part of this now is our parabola, so we're going to look at that next. So we're going to divide the sides up for our parabola. So we're going from this rectangle here, divide the sides up into the same number of equal parts. So I'm going to do 5 equal parts. So that'll be 29s. And then for the bottom, 5 doesn't go into 104 evenly, so we're going to have to take a line off at any angle, mark off 5 equal sections, then using the sliding set squares, join to the end point, which is point S. So joining the last point to point S, and then taking our lines parallel to that from each of the points. So next what we're going to do is we're going to label, so this is point A, I'm also going to call it 0, 1, 2, 3, 4, and then you got 0 again, 1, 2, 3, and 4. The ones down here at the bottom, which are on the line, so they're perpendicular, or they're in, this one is cut by the axis, this is our axis, we're going to go parallel to the axis, so up along this way. And then the points up this side which aren't touching off the axis line, they join to the vertex. So where all the 1 lines cross each other is a point on the curve, the 2 lines, the 3 and the 4. Now we can draw the best curve that we can that will go through each of these points. And that gives us the parabola. So we're getting there with this question. A few more bits that we still need to do. We still need to do the similar portion of the ellipse up here, and we have an arc and stuff to do down here. So we're going to do that arc now first, down at the bottom. So this is 104 or 52 wide each on either side of the center, which we need. And we're also given a point P, which is up 16 millimeters off this base. So this is point P. So we have APS. This is an arc. So what we're going to use is we're going to use the idea of chords. So the joining A to P and bisecting that line, the center will be on the bisector. We already have one chord. The line AS is a chord for this arc. This line here is so that's a chord. This is a bisector of it. It cuts in half, so our center is going to be somewhere down along this line. So what I'm going to do now is I'm going to join either A to P or P to S. It doesn't matter which one. You can do both if you want, but you're just adding time. So bisect this line. Bisecting that, and then our center is down underneath this. So where that line intersects with the line which bisected the line AS will be the center for our arc, which has gone quite a good bit down on the page. So point for a compass where those 2 lines cross. Pencil on point S or point A or point P. They should all be the same. And then drawing an arc that passes through each of these points. So that gives us our arc down the bottom. So what we've done here is we've bisected 2 chords. One of them is already done, that's AS. The second chord then is bisecting PS or AP. Next we're going to look at the circle here and the tangent to it. So there's a small circle here of radius 12. So finding the center for that, just adding 12 onto the end of the minor axis and drawing a circle. So just drawing that lightly first, and now what we need to do is we need to draw a tangent or S, so point R is up here somewhere, and that's the point of contact between this circle and a tangent joined down to S. So first things for any straight line tangent, we're going to join center to the point outside of the circle, bisect this line, so swing an arc over halfway. That bisects it, and now what we're going to do is put the point of our compass on the bisector, pencil onto the center of the circle, and swing an arc so that it cuts the side of the circle. Where it cuts the side of the circle, that's our point of contact for the tangent. So we can now join point S to point, the now found point R, and that is our tangent. You can darken this in by very carefully tracing over it, or probably better just to use your compass. So that gives us that circle down here. There's one other circle on this, which is a circle drawn from the focal point from F and the radius is up to the end of the major axis, so just drawing a circle here. So that gives us the circle for this piece. The final part of it then is the similar ellipse, which is up here. So to get this we need to find point L. So point L is directly above the focal point, and it is 35 millimeters above B. So up here, this is point L, and it's a dark line just here. So now we're told that this is the curve LM with vertex at L is identical to a portion of the ellipse. So this is a part of the same ellipse. So up here, this curve is the same ellipse as this one. Normally we'd copy the same part of it, so that would be this bit down here. But as we don't have, I haven't drawn that bit, you can use any other bit. So this would be one of the endpoints, so we can use either this side or that side and mirror it. That's up to us. So what I'm going to do is I'm going to take sections here of 10 millimeters. So I'm measuring out here 10 millimeters. And that's going to give me 4 or 5 different coordinate points. That gives me 5 points down along here. I'm going to find those same points down along this way. So down 10, 20, the same distance sections. If you use 15 mil sections there, that's fine. And taking these lines out to the left here. So the final part of this then is, so this was the end point, that would be point L. So for the first point down, measuring from the axis line out to the point on the curve, to the end of the curve, that gives me this point. Doing the same thing for the next one down, measuring this distance here, third one, and so on. So I'm going to keep going down until it passes through the curve that we have, the parabola that's there. So I'm not quite there yet, so I have to go for the final point, which is this one. And then, as always, best curve that we can that joins up all of these points. And then darkening the outer part. And then that completes the this question.